Go.
Today we are teaching polynomial theorems by Sahina, Sarah, Hannah, and Ella.
Go.
The factor theorem states that for polynomial f, x minus c is a factor if f of c equals 0. This is saying that when c is plugged into the equation, the remainder or y value is 0. So you know what to write? For example, we are trying to see if x minus 2 is a factor of the same equation x cubed minus x minus 6. Therefore, we would plug in the root, x value 2, into x cubed minus x minus 6. Since the remainder or y value is 0, we can conclude that x minus 2 is in fact a factor of x cubed minus x minus 6. The remainder theorem is defined as, for a polynomial f, if f of x is divided by x minus c, the remainder is f of c. Therefore, if the remainder is equal to f of c, we can plug in the x value c into the equation to find the remainder. With this method, we can conclude the remainder is equal to the y value. Yeah, just keep recording. Let's determine if negative 2 is the root of the equation x squared minus x minus 6. Hence, we would be dividing the equation x cubed minus x minus 6 by the factor x plus 2. So we plug in negative 2 into the equation. Therefore, the remainder is negative 10. Since there is a remainder, we conclude that negative 2 is not a root of the equation x cubed minus x minus 6. The factor theorem states that's it, we're good. We're done for that. Oh, wait! conjugate theorem is that if a plus bi is a root, a minus bi is also a root. Let's look at these examples. The first question is, if one of the roots is 3 plus I, what is the other root? By using this theorem, we know 3 plus I conjugates with 3 minus I. The rational root theorem is for polynomials in standard form with integer coefficients. P divided by Q reduced is a possible root if P is all factors of the constant and Q is all factors of the leading coefficient. For the example, to find possible roots from f of x equals 2x squared minus 3x plus 12. Find the factors of p of 12 and q of 2. Factors of p and 12 are plus or minus 1, 2, 3, 4, 6, and 12. And factors of q of 2 are 1, 2, 1, and 2. Then you put all the numbers on p divided by q. Then the possible roots come out, which are plus or minus 1/2, 1, 3/2, 2, 3, 4, 6, and 12. The intermediate value theorem is for a continuous function f if a is less than b, and if f of a and f of b are opposite signs, then f must have at least one root between x values a and b. There are 3 points that make this theorem true. 1. The x values of a have to be less than b. 2. The graph has to be continuous. 3. F of b and f of a have to have opposite signs. If these are all proven true, then the polynomial function will have a root between the x values of a and b.
The extreme value theorem is defined as if f is continuous on a closed interval a, b, an absolute minimum and an absolute maximum must exist. The function must follow these rules. The function is continuous, the function has a closed interval a, b, If both of these points are proven true, there will be an absolute minimum and absolute maximum. For example, on this graph, the function is continuous and also has a closed interval. Since both of these points are proven true on the graph, the function must have an absolute minimum and an absolute maximum.
Thanks for watching.